Today we're going to look at a new meter, and I know I'm going to butcher the name. I think it's FNIRSI. Is that how it's pronounced? DMC100 is the model. I think this one's a winner. It does everything. It does AC current measurement, DC current measurement without actually connecting anything. It's an inductive loop. Voltage, resistance, capacitance measures, diode testing. It's got a thermometer, measures the frequency. It'll do your calculations on how many watts you're drawing. Oh, it's amazing. Check this one out. Let's take a look at what this one, the DMC100, does. It has AC and DC current measurement, AC-DC voltage, resistance, continuity, diode testing, capacitance testing, frequency, temperature, has an NCV for live testing, and 2-inch color screen. It runs off of a 3.7 volt lithium battery and charging a USB Type-C at 1 amp. Maximum jaw size 25 millimeter. We're going to test all this. So it has a flashlight, an auto power off, data hold, intelligent anti-burning. I guess that's for the screen. And we're going to open this up, break the seal, and we'll take a look at it and try it out. I've got my test cable here for testing. We'll be testing current with the current clamp with my little modified cable. So here is the meter, and it comes, of course, with destruction manual, temperature probe, test leads, charging cable. Here it is. Actually, it's quite small. Will I be able to pull this off without breaking it, without it tearing? That's usually what happens with me, is the little tab tears off and the rest of it stays behind. All right, first things first, let's power it up. See if the battery is charged. It is, of course. Now I got to select English or Chinese. I take it, I just press, uh-oh, I selected the wrong input. How do I fix this? I don't want that. I don't want it in Chinese. I want it in English. I got to look at the manual to see how to change the stupid thing. Okay, let me just, I'm going to press the save, long press the save button. Alright, now let's just see if I can figure out what I'm doing here. I go to this. Oh, there we go. Okay, how do I select English? How do I select English on this thing? Okay, I know that that's the one I want to do, but how do I change it? There we go. Okay, now, there we go. Okay, now I'm in English. Okay, now I'm happy. I got it down to English. Alright. No, don't do that. Reset all settings. Okay, now that I'm out of this, press and hold maybe. Okay, there we go. All right. Starts out in ohms mode. We can change the modes here. Voltage, amperage, ohms, capacitor, hertz, and live, non-contact voltage. There's the sensor there. If I take my power cord, which is energized, and I bring this near here, it should tell me that I'm near a live. Non-contact. Non-contact. There we go. You see? If I get near the outlet that's hot, it'll beep. If I plug my little cheater cord in here, it should beep when I'm near the black wire, which it does. It doesn't beep near the neutral, and it doesn't beep near the ground. It beeps near the live wire, and there's probably a sensitivity on this too. If I press this one, that's live. Live is, I believe that's, you just plug in a probe, and you don't have to complete the circuit, you just touch it. I believe that's what live is doing. It's just going to tell you whether you got a live wire or not. So if I plug the probes in, because we're going to do some measurements with this thing, common is obviously the black one, and the red one to here. In live mode, I should be able to just touch either probe to any source of power. So in other words, if I take the black probe, that's live, right? You can just touch it. So you got your probe here, and I guess if you've got the cap on, nope, they don't protrude on there. That covers them right up. But you know, if I touch one that's not live, the neutral is not live, the ground is not live, but that one is. So that tells you that you're live. And if I touch it with this other one here, it does the same thing. It beeps and flashes that you are on a live circuit. So that's a live test. Press the mode button. It's non-contact, so these ones shouldn't do anything. Well, they do. They still do, but non-contact is you just hold this near your live wire and it will beep. It will find that you've got a live wire without actually touching the wire. That's your non-contact voltage. We go over to hertz, and if I plug this thing in here, it should tell me that the frequency is 60 hertz, which it does. You probably do it with either of the probes. Right, either probe will tell you at 60 hertz. Next is capacitance testing. I just had some caps here that I changed out. I guess I threw them in the garbage. I know they're bad, so I could have tested them. It's not ESR testing, I think it's just standard capacitor testing, but I could have tested a couple of bad caps. Oh, here's one. These are bad, but what's it going to tell me that they are? Just for the hell of it. Connect the... And it's only measuring, this is 1,000 microfarads, and it's only measuring 33. Yeah, because we know it's bad. This one had bad ESR. And it tells me that this was, 35 microfarads. If I compare it to the fluke, what does the fluke say that this one is? Capacitor. Well, the fluke's telling me it's 398. It's 1,000 microfarad though, so it's low on the fluke. But on this one here, it showed a much lower value than that. But I mean, we know it's bad. It's going to tell you it's bad. I'll grab a new cap as well, and we'll measure a new cap. But here it is again. It starts out at nanofarads. Gradually going up, but this should be hitting 1,000 right away. It tells me what my maximum was too. If I go to another cap, I don't know what shape this one's in. I'm sure it's bad because it was lying by the garbage can. Oh, this one's measuring 1.3. This is measuring actually 1,200. What is this thing? This is 1,000. It's measuring 1,200. This one's also a bad cap though. I think this one's got DC resistance on it. But it's way off, 1,000 should be measuring around 1,000. If we put this thing into, if I measure it on this other one, the other meter results are going to show that it's bad, and it's going to show too much, because this one here, I'm pretty sure has DC resistance. Yeah, 1,311. If I put the meter in, where are we here? Ohms mode. See, this capacitor is DC leaking. 847 mega ohms, or 0.8, so 840 K is what this one's measuring. And that is why the capacitance measures higher, is because there's leakage. And how the capacitor testers work is they apply a voltage across the cap and they measure the time it takes to charge up. But because the capacitor has internal leakage, it just never will charge up. It just continues to draw current, and it never gets up to like 30, 40 mega ohms. It goes to infinity. And that's how the cap testers test, is they measure how long it takes to put electrons into it, which should be blocked because it's DC. So the resistance should rise to infinity. But in this case, it's bad, and it measures bad. So that's another way you can test capacitors. But we knew this one was bad because the microfarads showed higher, right? Showing 1,300, right? Should be 1,000 microfarads, showing 1.3 millifarad instead of microfarads. So that's like 1200. If I put the meter into ohms mode here, we'll see that it's going to show me that it has bad leakage in it as well. This will go up, and it'll probably sit around the same as the other one. But this one's showing it's like 50K, but it's continuing to increase, and it'll probably start to go just shy of a mega ohm, just like the other one. Anyway, we know that cap is bad. If I grab a new cap, just for the hell of things, what have I got here? I'm just going to grab anything. This is a 47 microfarad at 250 volts. I'm just going to pull this one out, and we'll measure it on the fluke first. So, whoops, yeah, capacitor is now measuring 44.2. We'll short the leads together, and we'll go back and measure it on this one. Oops, might help if I put it in the right mode. Short the leads together. Start out with it completely empty. And there you go. 43. So it's measuring capacitors accurately for capacity measurement. Next, we'll put it in AC voltage, and we have 120.6 volts. That's accurate, and it's measuring. This one's measuring 121. 121.2, and this one was measuring 120.6, was it? 120.6. So we're within a volt. The fluke might not be accurate because it's old. This is very old, but it's in a ballpark. We're within a volt at 120 volts. We're within 1 volt. DC volts. We'll go to the DC voltage side of things, and we'll turn on the power supply, and I'll set it to some voltages, and we will measure the voltage. So I'm set to 5.5 volts DC, and we clip the meter on, and we have 5.58. We'll take a look at the same voltage here on the fluke meter, and we'll see that it is also measuring 5.58. The new one's measuring 5.582 because it's got an extra digit of accuracy, and I like that display. I really do. I like that display. I think we're going to be seeing this one on my bench. I really do, because I like the display. It's easy to read. It's nice and bright, you know, and it's got a rechargeable battery, and it does everything, you know. We'll turn the voltage up. We'll crank this voltage up here. Set it up to like 13.8. So 13.8 volts on my meter, on the power supply here, is measuring exactly 13.8 volts on the meter, and the fluke will get a reading off that. So we're. Any questions? We're right there. So voltage wise, seems to be pretty accurate. Let me max out my little power supply here. Turn it all the way up as high as it will go. 32.11 volts. And fluke measures the same, 32.1. So it's accurate. It's accurate. Next we'll test transistors and diodes and stuff, and then we'll do the current measurement. Current measurement is done with a clamp, and this is supposed to do DC through this inductive clamp too. So we'll be able to test that out. I'm going to test a diode here, so we'll put this into diode test mode. That's ohms. Press mode. That's a continuity, and that is diode. We'll test it first on the fluke. So I've got an NPN transistor here. I've got the positive lead on the base, and we'll see we have a voltage drop of 0.7 across the emitter base and collector base. And if I reverse the polarity, of course, it'll show as open. So I'll put the negative on the base. This is EBC, the basing of this one, and you'll see that it is open on the fluke. We'll go over to the new meter and test the same thing for testing diodes and bipolar transistors. If I put the negative terminal on the base, it's an NPN, so of course it's going to read open. And if I put the positive terminal on there, I'll get the voltage drop of 0.7. No beep, just the voltage drop. 0.72. That's testing transistors. Works like a charm. Next one is ohms. We'll check that in a second. Continuity. This is going to have a beeper. So when you're checking for continuity, this is low ohms. So that's testing transistors and testing continuity. And next we'll go to resistance measurements. This is a 8 ohm resistor, and the reason I grabbed an 8 ohm is I just stabbed myself. Things are sharp as anything, these probes. The reason I grabbed an 8 ohm resistor is because we're going to be using that for the DC current test in a minute. But 8 ohm resistor measures 8.2 ohms. And on the fluke meter, it's actually measuring 9.9 on the fluke. I think this one's probably more accurate. Oh, wait a minute. My fluke, my probes are, my test lead is 1.5 ohms because these test leads are in pretty sad shape. If you look at this one down here, it's starting to fray. I need new test leads. So that would explain why the measurements are a little bit off on the fluke, because the fluke, the test leads are just about done. For temperature, we can put the temperature probe in place of the meter, or the meter probes. And it has a little thermocouple on the end here that we can measure temperature with. So if I unplug the meter probes and plug in the temperature probes, and we'll select temperature, and it should measure the temperature that's in the room here. We'll see how accurate it is for the temperature in the room. So I select over to temperature, hertz, and temperature, and it says it is 22 degrees Celsius. It is not 22 in here. I'll tell you that much right now. It is not 22. It's maybe, I got the heat on it here now. My other thermometer says it's 19. But that may be because I was handling this thing too, right? Because if I touch it in my hand here, heat it up. But it's off by a couple degrees. But again, it's not. I haven't calibrated it or anything. But that's measuring temperature in Celsius. Okay, it seems like it's settling in around 351. My iron's actually set for 700. It's now settled down. 700 Fahrenheit, 350 Celsius. So it might be measuring a little bit cold. Although I don't know the calibration of my meter is 100%. It hasn't been calibrated in years. This is showing 353 degrees Celsius. What's 353 degrees Celsius? That's showing 667. So it might be off a little bit, or my actual weller might be a little bit cold, because it measures the temperature down here where the thermocouple is. The tip temperature is always going to be a little bit colder than the actual thermocouple that's inside here, right? So I know they tell you to compensate for that depending on the tips. Like if you have the longer tips, because you can get the longer tips for this, and they say you got to turn it up by like 50 degrees because there's a temperature difference between where it's measured, which is way down inside. Like I'll show you here. It's measured, right down here. If I pop the tip out, the thermocouple is right there, right down at the top there, you see? So it's measuring the temperature inside, and what's at the actual tip here is obviously going to be a little bit lower than that, but it's in the ballpark. The one thing left to measure with this is current. We're going to measure both AC and DC current, and this is where the resistor is going to come in handy, because I'm going to put a DC voltage across the resistor. I'll clip it right onto the resistor, and we'll set this for 1 amp. So it's 8 ohms, so 8 volts should give me 1 amp of current. My ammeter on my meter now is showing 1 amp. And I switch the meter here over to current mode, DC amps. There we go, amps. DC amps or AC amps. So DC amps, if I clip this meter on here, what is it telling me that I'm drawing? It's telling me I'm drawing negative 0.9. If I go to the other side over here, it's going to show that I'm drawing 1 amp. There we go. So it's actually measuring. It's measuring 1.1 amp of current, 1.06, and my ammeter on the power supply is measuring exactly 1 amp. So we're pretty close. If I show you the power supply, 1 amp, 8.6 volts. And that's taking into consideration the voltage drop on the wires. So we are pretty close, pretty good for that. If I turn the power up here, and this resistor is obviously going to start to get warm, which it is. If I turn this up more, I don't want to burn the resistor out, but we'll go to 3 amps. And we're at 3 amps now, and the current meter is showing 3.07. If I crank this up all the way, 3.8 amps. It's showing 3.8. And this is getting very hot, so I'm going to crank this thing way down. I don't want to burn the resistor out. And there's 1 amp there. So it's measuring current. I'm going to let that thing cool down. I have another resistor here. I don't want to burn this one out. This is a 5 watt, 1 ohm resistor. So if I put 1 volt across this one, we should have 1 amp. So let's just turn this down to 1 volt. And there we go. 1.07. And this is going to start to warm up too, I'm sure. It's a 5 watt, so we'll increase it to 2 amps. It's measuring 2.04 at 2.3 volts. So it is measuring DC current through the inductive loop. Let's measure some AC current now. I've got a few things to plug in here that will draw AC power, and we'll put this into AC amps by switching to that. I got some things that draw a bit of power. I got a heat gun. We'll plug that in. Turn it on. So these are higher power devices, obviously. And to measure this power, I'll just set it up like that so nothing burns. We just have to, we can measure either on either the white or the black wire. So if I clip on the clamp onto the black wire and turn this thing on, 6.4 amps is what it is drawing. To go to high power, 11.5 amps. A little bit of math. It's how many watts is this thing? It's 1350 watts on full power. That should draw about 11.25 amps according to my calculations on my little calculator here. It should settle in once it warms up, because of course the resistance will go up a bit. But so it's measuring 11.5, and calculations wise it should be about 11.25. It's close. It's very good. There's nothing wrong with that measurement. Now I'm going to watch it here. I'll probably melt these wires. I don't think this thing's rated for more than 10 amps, this cable. It might only be rated for 7, but it's giving us an accurate read. So everything's looking good. Everything's accurate. I'm liking this unit already. It has a flashlight in it too. Oh, the flashlight's on. Where did I turn that on? There's a button on here. Of course, the flashlight's controlled by the flashlight button on the side. You long press it to turn it on or off, which is good if you're working in the dark and you're measuring current. This is what this is more for than anything. If you're working in the dark and you need to see what you're clipping onto to measure, you've got a flashlight, and this lights up nice and bright so you can see what you're doing. The charge port is underneath here for updating and for charging. USB-C. You can update the firmware when firmware is released from your computer through that USB port. And of course, charge up the battery once it needs to be charged. Another feature I found on here is if you press and hold the right arrow key, it will go into a mode where you can measure current and power at the same time. So for example, try to do this without blowing myself up, but if I go to the plug here and I put my probes on here, it should measure the voltage. Getting 117 volts right now because of a bit of a voltage drop across this cord. But as you can see, I'm drawing 11.2 amps, 117 volts AC. Very useful feature. If you're looking for voltage drops in current and so forth, you can measure both your current consumption and your voltage at the same time. I go down to the lower power and it'll probably, yeah, there my voltage is coming up. And the reason why I was getting a voltage drop is because this little cable that I made up here for testing, for breaking out for current, this is only rated at, I believe, 7 amps. What's it say on here? It's not a big cord. It's a extension cord set, and where's the current rating on this thing? I think it's 7 amps. If I press this button and hold it, that will hold the display so that you can take your measurement and lock it on the display. Press and hold, and we'll hold it. And it tells me right here, oh look, right here, 736 watts is what I was drawing. If I unhold the display, I didn't even notice that before when I was looking at it. If I turn off this dual display, does it tell me watts? I guess it just tells me amps here. So if I plug it in and turn it on, you have to be in dual display mode because of course this is measuring your current, right? But it's not going to tell you how many watts you're drawing. If I put it into the dual reading mode and we measure the voltage as well as the current, so if I put my probes on here, (117.3 volts). It's 1.341 kilowatts. That's drawing 11.4 amps. That's kind of neat. So it'll tell you your wattage. You know, 1,341 watts is what it's drawing. And this is registered at 1,350 is what this is. If you can read that. So it's a neat tool. I'm liking it. I think we're going to probably see this one end up on my bench a fair bit. It's because it's small and it's got a nice display. I like the display on here, and it's accurate, and it does everything, including current. The Fluke doesn't do current. This does current, AC and DC, and it does it without having to actually break the circuit. Most ammeters, you have to put them across and measure through the meter because the current loop is inside the meter. This one here, it's an inductive loop. That works well. I like it. Anyway, I'll put a link in the description where you can get one of these little meters. I think we got a winner here, folks. Thanks for watching. We'll catch you in the next one. Bye.